So let us start with the chapter of permutation and combination again. In the last two classes, we have seen about what are the concepts, and we have seen some of the question. Now let's practice some of the more question and try to clear our concepts more. So look at this question. It is saying a mother with 7 children takes 3 at a time to a cinema. She goes with every group of 3 that she can form. How many times can she go to the cinema with distinct group of 3 children? Okay. So basically there are 7 children and she takes 3 at a time to cinema. She goes with every group of 3 that she can form. Okay. And how many times can she go to the cinema with distinct group of 3 children? See, here only you have to consider about selection. Okay. You have to just consider about selection. So I hope everybody is clear with this thing that you have to just consider about selection here. So like she has 7 children, A, B, C, D, E, F, G. Okay, so these are several children. Okay, so either she can go with A, B, C, B, C, D, C, D, E. So in this way, what are the number of combinations you are going to make? That only the question is asking. So the simply the answer becomes 7C3. So this question is that simple. We just have to recognize that what we want in this question. Now look at this question. For the above question, how many times will an individual child go to the cinema with her before a group is repeated? Okay, so it is asking how many times a individual child will go. Okay, so see what the question is asking here. For example, you have this children A, B, C, D, E, F, G. Okay, so let us start with this group. So either A, B, C can go to the cinema, or A, B, D can go to the cinema, or A, B, E can go to the cinema, or A, B, F can go to the cinema, or A, B, G can go to the cinema. Okay, this way. Or if you take C, so either ACD can go to the cinema, or either ACE can go to the cinema, or ACF can go to the cinema, or ACG can go to the cinema. Okay, now if you take now you will have ADE will go to the cinema. Now A is there but no group is repeated until now. Okay, understand this thing. A is there but no group is repeated till now. We don't have to calculate in this way. I'm just trying to explain what the question is asking you. Okay, either ADE can go to the cinema, or ADF can go to the cinema, or ADG can go to the cinema. Similarly, AEF can go to the cinema, or AEG can go to the cinema, or AFG can go to the cinema. Okay, so now I think almost all the groups are made. Okay, so you count, you are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 times you are getting. Okay, but we don't have to find in this way. When we are doing permutation and combination, we don't have to find in this way. Okay, we have to find how. See, basically, um, for example, you fix a child. Okay, we have 3 places. Okay, we have 3 places because at a time 3 children can go. So fix a child. So let us fix A here. Now she has how many choices to how many options to fill these 2 choices? Out of 6, she can take any 2. Okay, so that will give you the same number. So 6C2 you do. Okay, because A we have already fixed, we can't do anything about that. So both of these child can be picked up from these all 1, 2, 3, 4, 5, 6. Okay, so you can do this in 62 ways. Okay, so that will become factorial 6 divided by factorial 2, which is nothing but 6 into 5, sorry, factorial 6 divided by factorial 2 into factorial 4. Okay, so that is 6 into 5 divided by 2 into 1, so you get this as 15. So I hope you understand how can we do this in formula way. See, here it was only 7 children, so I could make it out by this way. Okay, but when there are more children, so then you can't make it out by this way. You will have to do it in by method of combination and permutation. Okay, you will have to do it by the method of combination and permutation. So I hope you understand. Let us look at this question once more. See what the question was saying, that in how many times will an individual child go to the cinema with her before a group is repeated. So that means what, if we have like 7 children, A B C D E F G, okay, um, okay, so how many times an individual child will go to the cinema? So when we are doing mathematically, what we did here was we fixed this one in place A, and then we have left two places. And when we have left these two places, then how many options we are having? We have to select two out of these six. So this becomes 62 ways. And 62 is what? Factorial 6 divided by factorial 2 into factorial 4. So this is nothing but 6 into 5 divided by 3 into sorry, 2 into 1. So this is given by 15. Okay, this is given by 15. So this is how we do these kind of questions. Now let us look at this. Okay, how many different sums can be formed with the following coins? 5 rupee, 1 rupee, 50 paise, 25 paise, 10 paise, 1 paise. Okay, how many different sums can be formed with the following coins? 5 rupee, 1 rupee, 50 paise, 25 paise, 10 paise and 1 paise. Okay, so obviously how many different sums can be formed? See, basically these are what? These are these are 6 coins of different denomination. Okay, now see what they are asking basically, that how many sums can be formed. Okay, now see, either you can select one coin, or you can select two coin, or you can select three coin, or you can select four coin, or you can select five coin, or you can select all 6 coins. Okay, so that is see, we did one thing, that number of combinations. Okay, number of combinations uh, possible. Okay, so that is given by when you are selecting only one. So this you can do in how many ways? NC one ways. Okay, so you have how much? You have this 1 2 3 4 5 6. So 61 ways when you are selecting only one denomination. When you are selecting two denomination, you can do it 62 ways. When you are selecting 3, 64 ways. When you are selecting 4, 64 ways. Okay, when you are selecting 5, 65 ways. And when you are selecting 6, 66 ways. Okay, 66 ways. Okay, so this is what you can do. Now see, this is given by 2 to the power n. Here n is what? N is equal to 6. Okay, 1 2 3 4 5 6. But we are not considering the case where we have 0. We are selecting 0. So we'll do this minus 1. Okay, 2 to the power n minus 1 will do. Okay, so this will become 2 to the power 6 minus 1, or you can calculate from here also. This will become what? Factorials, this will become 6 only, है ना? This will become 15. Okay, this will become 6 into 5 into 4 divided by 3 into 2 into 1. Okay, this will become 6 into 5 into 4 into 3 divided by what? Divided by 4 into 3 into 2 into 1, and so on. Okay, so this is how you can do these kind of questions. See, we already did this case. Okay, we already this concept. See, in how many ways you can combine. Okay, these, either you can take one coin, or you can take two coin, or you can take three coin, or you can take four coin, or you can take five coin, or you can take 6 coin. So when you are taking one coin out of 6 coin, you can do this in 61 ways. Okay, when you are doing this, you can do this in 62 ways. When you are doing this, you can do this in 63 ways. When you are doing this, do this in 64 ways, 65 and 66. But we already know NC0 plus NC1 plus NC2 dot 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 NCN is given by 2 to the power n. So NC1 plus NC2 dot dot NCN should be given by 2 to the power n minus 1, because NC0 is what? NC0 is 1 only. Okay, so this becomes what? 2 to the power 6 minus 1 ways you can do it. Okay, so I hope everybody is clear with this. Okay, so but it in here, if you are considering this case, see, the coins are so much of different denominations, that if we add two coins, no two sums will be same. Okay. So for example, if we are adding 5 rupee and 1 rupee, we are getting 6 rupee. If we are adding, let's say, 5 rupee and 25 paise and 50 paise, then we are getting 1.75 rupees. Okay. So this way, but sometimes it will happen that when you take certain denominations, your sums will be repeated. For example, if you take 5 rupee, 1 rupee, 50 paise, 25 paise, 3 paise, 2 paise and 1 paise. Okay, 3 paise, 2 paise and 1 paise. So in this case, we'll have to subtract some values for double counting. Okay, in this case, we will have to subtract some value for double counting. Why? Because if you consider this 2 plus 1 plus 3, so this will become what? This will become 5. So when you are doing 25 plus 5, this will become 30. Okay, or this will become 55. Now when you are adding these, so some will lead to double counting, so we have to subtract that. So be very careful when you add these kind of things. Okay, now I hope you are very clear with this thing. Now let's move forward. Okay, now look at this question. A train is going from Mumbai to Pune and make 5 stops on a way. Okay, and make 5 stops on a way. Now 3 persons enter the train during the journey with 3 different tickets. Okay, how many different sets of tickets may they have had? See, basically it is saying train is going from Mumbai to Pune and makes 5 stops on the way. So 1, 2, 3, 4, 5. Let's say these stops are A, B, C, D, E. See, you don't have to make these arrangement while you are solving the question. If you are able to directly put your formula here, it's very good. But I'm explaining to you because first you should, in certain questions, you should be able to visualize the question. Okay, because when you visualize the question, you become very clear that which formula we have to apply, how we have to apply, what are the variables. Okay, so I hope you understand with this thing why I'm explaining these arrangements to you. So now it is saying a train is going from Mumbai to Pune and make 5 stops on the way, and 3 persons enter the train during the journey with 3 different tickets. How many different sets of tickets they have had? Okay, so we are going from Mumbai to Pune, है ना? And we have 1, 2, 3, 4, 5 different people in the journey. Okay, we have 1, 2, 3, 4, 5 different stops in the journey. Okay, 5 stops we have on the way, and 3 persons enter the train with 3 different tickets. So if they are having 3 different tickets, so they are entering from one of these different stations. Okay, from one of these different stations. So how many different sets of tickets may they have had? So basically, see what this question is asking, that let us say if they are entering from this ABC, one person is coming from this A station, one person is having from this B station, and one person is having from this. Okay, so one person is entering from A station, one person is entering from this B station, and one person is entering from the C station. Now, the person from entering this A station can either go to B station, okay, and can either go to C station, or can either go to D station, or either go to E station, or can go to Pune as well. Okay, or can go to Pune as well. Okay, so how many tickets this A person can have? This A person can have 1, 2, 3, 4, 5 tickets. Okay, now this B person can have this many tickets, C, D, E, and P. So this one can have 4 tickets. The person who is entering from C, he can have how many tickets? D, E, P. So he can have this 3 number of tickets. Okay, the person who is entering from this D station can have 2 tickets. Okay, and the person who is entering from this E station can have 1 ticket. Okay, so number of tickets this one person can have is, the person who is entering from A is 5 different kinds of tickets. Number of tickets this person entering from this B station can have is 4 different kind of tickets. Okay, number of tickets this person entering from C station, 3 different kinds of tickets. Number of person entering from D station, 2 different kinds of tickets. And number of any person entering from E can have 1 different kind of ticket. Okay, now see what we are having. We are having these many different kind of tickets we can have. Okay, now See, we cannot multiply in this. Why? Because these events are mutually exclusive. So, a person, if any person is entering from this A, okay, if any person entering from this A, so then another person will enter from B, C, D, or E only. Okay, so this can have only 5 tickets only. Okay, and then because these are mutually exclusive events, okay, mutually exclusive, okay, so, because if one event is happening, the other cannot happen. Okay. So, see what you will do here is you will add. Okay. So, you will add means 4. Okay. And then you will add means 3, because these are the combinations of the ticket you can have. Okay. So, you will add this 5 plus 4 plus 3 plus 2 plus 1. Okay. So, how much you are going to get? You are going to get 15 tickets. Okay, there are 15 set of tickets available. Okay, these are what? These are 15 set of tickets available. Okay, but there are 3 persons and they can choose from any different any of the 15 set of tickets. So you can do this in 15C3 ways. Okay, so you can do this in 15C3 ways. So this will be our final answer. Okay, this will be our final answer. See, understand once more what the question is saying. A train is going from Mumbai to Pune and makes 5 stops on the way. 3 person enter the train during the journey with 3 different tickets. How many different set of tickets may they have had? Okay, so what this is in, first you have to find the number of tickets that can exist between Mumbai to Pune with 5 stops on the way. So number of tickets existing between Mumbai to Pune with 5 stops on the way will be A, B, C, D, E. Okay, A, B, C, D, E. Okay, number of tickets from Mumbai to Pune with 5 stops on the way can be given by A, B, C, D, E. Okay, now we are saying we have to find how many tickets are possible. Okay, how many tickets are possible? So from A to P, how many tickets are possible? 5 tickets are possible. From B to P, how many tickets are possible? 1, 2, 3, 4. 4 tickets are possible. Similarly, from C to P, how many tickets are possible? 3 tickets. From D to P, how many tickets are possible? 2 tickets. And from E to P, only 1 ticket is possible. Total number of tickets possible are 15. And we have to, these 3 persons have to choose from any 15 tickets. So this can be done in 15C3 ways. Okay, this can be done in 15C3 ways. So 15 into 14 into 13 divided by 3 into 2 into 1. Okay, so this is how we get. Okay, this is how we get. Fine, fine. Um, Now look at this question. Okay, find the number of diagonals and the triangles formed in a decagon. Okay, now see, decagon means um, decagon means any quadrilateral. Okay, any quadrilateral. Actually, will not say it quadrilateral. Decagon means a closed figure with 10 sides. Okay, with 10 sides. Okay, decagon means a closed figure with 10 sides. Okay, so how you can make 10 sides? Okay, let's say this. Okay, so consider this, that this decagon has 10 sides, means these have 10 points. Okay, these have what? How many number of points? 10 points. A decagon has 10 points. Okay, consider this thing. A decagon has 10 points. Let us say we try to make this as well. uh, okay, 1 2 3 4 5. We are having 1 2 3 4. These are how many points? These are 1 2 3 4 5 points. Let us make 5 more points. Okay, so 1 6 it is, now 7 it is, now 8 it is, now 9 it is. Okay, now let us say this is 10. Okay, so we are having, so this is a decagon है ना, and this has how many points? This is 10 points. Okay, now it is asking find the number of diagonals. Okay, so there are 10 points. How many lines can be formed out of them? 10C2 lines can be found out of them. Now but this is asking about diagonals. Okay, so when we are in this 10C2 lines, these sides are also included. Okay, these are not diagonals, these sides are included, but these are not diagonals. Okay, so how many sides are there in a decagon? 10 sides are there in a decagon. Okay, so you just subtract 10c2 minus 10, so you get your number of diagonals. Okay, so when you subtract 10c2 minus 10, so you get your number of diagonals. And what about triangles? Okay, what about triangles? We have these triangles. Okay, so a triangle is formed by the combination of three vertices. Okay, or 3 points. Triangle is formed by the combination of 3 points. Okay, so that can be done in 10c3 ways. This is very simple. Okay, I hope you understand this. See, in the first question when it was asking about diagonals, okay, so then uh, similar, it is very simple. A line is formed by combination of 2 points. Okay, a line is formed by combination of 2 points, so that can be done in 10c2 ways. Okay, that can be done in 10c2 ways. But uh, uh, so this can be given in 10c2 minus 10 ways. Okay, 10c2 minus 10 ways, because we are excluding the sides of the decagon. Okay, we are excluding the sides of the decagon here. And in case of triangle, it is formed in 10c3 ways. Okay, it is formed in 10c3 ways. So I hope you are very much clear with this concept. Let's move on to the next concept. It is saying out of 18 points in a plane, no three are in a straight line except five which are collinear. How many straight lines can be formed? Okay, so out of 18 points, okay, out of 18 points in a plane, no three are collinear. Okay, no three are collinear. It is saying how many straight lines can be formed. Okay, so there are 18 points. Now, if there are 18 points and all of them are non-collinear, all of them are non-collinear means no 3 points lie on the same line. Okay, collinear, see, any 2 points can lie on the same line. We can draw a line through any 2 points. Okay, but if 3 points are on the same line, we say that these 3 points are collinear. Okay, if 3 points lie on the same line, then we say these 3 points are collinear. So similarly, it is saying that 18 points are there in a plane and no three are in a straight line except five are collinear. So no three are in a straight lines means no 3 points are are in straight line, but 5 points are collinear. Okay, 5 points are collinear means they are lying on the same line. Okay, they are lying on the same line. So if we make a combination of any two of these points, let's say 5c2, so they are lying on the one same line. So we have to consider this case as one only. Okay, we have to consider this case as one only. So when we are considering 18 points which are non-collinear, how many lines you can make? From 18 points which are non-collinear, okay, from 18 points which are non-collinear, we can make 18 C2 lines. Okay, we can make 18 C2 lines. But there are 5 points which are collinear. Okay, so we will subtract the number of lines they are making. So they can make 5C2 lines. So we'll subtract the number of lines from 18C2. But these five collinear points are making one line also, na? So we can subtract one from here, because we are going to subtract this many number of line, but we have to keep one. So we will subtract one from here. So this answer will become 18C2 minus 5C2 plus 1. Okay, 18C2 minus 5C2 plus 1. I hope you are able to understand this. Let us understand this once more. See what the question said. There are 18 points in a plane. Okay, and it is saying no three are in a straight line, because they are saying that 3 points are not collinear here, but 5 points are collinear. Okay, 5 points are collinear. So when I have to make uh, lines out of 18 non-collinear points, I can do this thing in 18C2 ways. When I have to make lines out of 5 collinear points. Okay, I can do this only in one way, but I will have to subtract the combination, the 5 non-collinear points that I have considered here. So I will subtract this 5C2 and I will just add plus 1 here. So this becomes 18C2 minus 5C2 plus 1 way. So I hope everybody is clear with this thing. Okay, I hope everybody is clear with this thing. Now let us move forward. So now they are now let us move on to the next question. Now they are asking for the above situation how many triangles can be formed. Now you know triangles can be formed out of 3 non-collinear points. Okay, triangles can be formed only out of 3 non-collinear points. Okay, so we have 1, 2 and 3 points that are not collinear, so we can form a triangle. We have 18 points. Okay, so in the previous question we are given 18 points and 18 non-collinear points. We can form 18 C3 triangles. Okay, and for 5 collinear points, how many triangle you will be forming? There are 5 points that are lying on the same line. How many triangle can you form? None. Okay, none. So you will do what? You will just subtract 5C3 from here. Okay, because out of the combination of 3 points you will form one triangle. Okay, but here because these points are collinear, you cannot form any triangle. Now there are 18 points. Okay, now there are 18 points, 18 C3 triangles. Okay, now there are 18 points, 18 C3 triangles. Okay, so but you have considered the triangles in which you are having. Okay, you have considered the triangle in which you have added those triangles which were made from this 5 collinear points. But by 5 collinear points, we cannot form any triangle. So this can be done in 18C3 minus 5C3 ways. Okay, 18C3 minus 5C3 ways. So this is how you do these kinds of things. Okay, so now let's move forward. Now look at this. A question paper had 10 questions. Each question only be answered as true or false. Each candidate answered all the questions, yet no two candidates wrote the answers in an identical sequence. How many different sequence of answers are possible? Okay. Now see what they are saying. A question paper had 10 questions. Okay. And each question can only be answered in two ways. That is either true or false. Okay, either true or false. And how many students are there? Each candidate uh, um, equation paper equation, each candidate answer all the question, yet no two candidates wrote the answer in an identical sequence. How many different sequence are possible? Okay, how many different sequence are possible? Okay, so we have to basically find out the type of the sequence. Okay, we have to find out uh, okay, we have to find out the type of the sequence, different type of the sequence that we can form. Okay, so for example, if first answer is coming true, so all answers are coming true, that is one sequence, and then one answer is coming false and rest all are coming true, that is one sequence, and then let's say the third answer is coming false. Okay, and other are coming true, so that is one sequence. Okay, so see how we'll do this. See, basically this first answer, these are 10 answers. First can be answered in two ways, second can be answered in two ways, third can be answered in two ways, and so on. Okay, and how many total boxes are to be filled here, or how many places are to be filled here? See, the total number of places that have to be filled here are 10. So you will do 2 into 2 into 2 till 10. Okay, so 2 to the power 10 ways. Okay, 2 to the power 10 ways you will have. So this is simple. Okay, this is simple. This will come 2 to the power 10 is equals to 10 1024. Okay, this is very simple. I hope everybody is able to get it. See what we are having. We are having 10 questions. Okay, and we have to find the number of different kinds of sequence. So that is basically what? Nothing but in how many ways you can answer these. So each of the place you can mark two kinds of answer. Either you can mark true or you can mark false. Okay, so this one either mark one true or false, this one two, this one two, and so on. So you will get what? 2 to the power 10. So this is how you do these kinds of questions. Okay, now look at this question. When 10 persons shake hands with one another, in how many possible In how many ways it is possible? Okay, so there are 10% shaking hand with one another. So basically you have to select two persons for a handshake. So you can do this in 10C2 ways. Now what is 10C2? 10 into 9 divided by 2 into 1. Okay, 10 into 9 divided by 2 into 1. See, whenever you are doing combination, now what you can do, the number of times you open this, like two times for two digits, 10 and 9, and you multiply this 2 into 1. Okay, so that also gives you your good your value. Okay, because if you see 10C2, that is given by factorial 10 divided by factorial 2 divided by factorial 8. So basically 10 into 9 and factorial 8 and factorial 8 here and factorial 2 here. So just just cancel this, so you get 45. So basically whenever we are doing factorials now, so how many times you are going to open this? So 10 into 9 divided by 2 into 1, this many times you are going to open this. Okay, so whatever this is given, you have to open this factorial that many times. Okay, so 10 into 9 divided by 2 into 1. If you are given, let's say 5 or let's say 8 c 6. Okay, so that means 8 into 7 into 6 into 5 into 4. Okay, into 3, you have opened this 3 times, sorry 6 times, and you can write this as 6 into 5 into 4 into 3 into 2 into 1. Okay, so this much is cancelled, this much is cancelled, so you get your answer as 28. Okay, so this is how you like you can calculate your combination. So we get here 45 ways. It's very simple. Okay, now let us move to the next question. It is asking, where did it go? Yes, it is asking, in how many ways can four children be made to stand in a line such that two of them, A and B, are always together? Okay, see, when four children are asked to stand in a line, so basically they are asking about arrangements. Okay, basically they are asking about arrangements. Okay, so and if A and B are always together, we consider them as one. Okay, we consider them as one. Okay, so there are four children uh, in a line such that two of them, A and B, are always together. So we are considering them as one. How many more children are left? Three. Okay, so three children have to be arranged. Three children have to be arranged. So we can do this in factorial three ways. Okay, we can do this in factorial three ways. So the answer should come as 6, but it will not come as 6. Why? Because AB standing this way and BA standing this way are different kinds of arrangement. Okay, are different kinds of arrangement. So AB can themselves be together arranged in factorial two ways. So multiply factorial 2 here. So this becomes 12. Okay, so your answer comes 12. So now see, if your answer comes 6, that will be wrong. Okay, if your answer comes 6, that will be wrong. Why? Because you have to consider that if these are exchange, if B and A exchange places, then that is one more arrangement. Okay, so your okay, fine. Now it is saying each person's performance compared with all other person is to be done to rank them subjectively. How many comparisons are needed to total if there are 11 persons? Okay, if there are 11%. Now each person performance compared with all other person is to be done to rank them subjectively. Okay, each person's performance compared with all other person is to be done to rank them subjectively. How many comparisons are needed to total if there are 11%? Okay, if there are 11. So see, the question, when it is saying each person's performance is to be compared with all other person, is to be done to rank them subjectively. Okay, so there are 11 persons. Okay, so when you have to like compare each one with the other, so that means you have to compare two persons, and 11 persons how can be compared in a set of two persons? 11 see two ways. Okay, 11 see two ways, so 11 see 2 will give what? 11 see 2 will give 55. Okay, 11 see 2 will give 55. See what this question is saying, each person performance compared with all other person. Okay, so that means let's say we are having 7 person. Okay, A B C D E F G. These are 7%. So we'll compare this with this one, we'll compare this with this one, we'll compare this with this one also, and this one also, and this one also. So basically 1, 2, 3, 4, 5, 6. So 1% we are comparing with 6%. Okay, then this person will also be compared in a similar way with this one. So that will be the same case only, but this one, this one, this one, this one. Okay, so that is the number of cases you will go on adding here. Okay, so this is nothing but just like a handshake. Okay, so that can be done in 11C two ways. Similarly, comparison can also be done in 11C two ways. So that is 11 into 10 divided by 2 into 1. So that will give you 55 comparisons. Okay, again this question is coming. A person X has 4 notes of rupee 1 to 5 and 10 denomination. The number of different sums of money she can form from them. Okay, the number of different sums of money she can form from them. Okay, see, that is given by what? NC1 plus NC2 plus NC3 plus NC4. Okay, and this is nothing but 2 to the power 4, and we are not considering NC0, so we will subtract this here. Okay, so here n is what? 4 only. Here n is 4, so this is given by 2 to the power 4 minus 1. Okay, see, this is the question, the similar question we did already. We are given 1, 2, 5 and 10 denominations. Okay, we are given 1, 2, 5 and 10 denominations. So this can be done in how many ways? Okay, so you form, either you add these and do this, or you can add this and this, or you can add this and this, or this and this, or this and this. Okay, so that can be done in how many ways? NC1 plus NC2 plus NC3 plus NC4 ways, and that is 2 to the power n minus 1, because we are not considering that case in which we are not choosing any of the rupee note. Okay, so NC0 we are subtracting, so this becomes this. Okay, so this becomes 2 to the power 4 minus 1. And what is 2 to the power 4 minus 1? Obviously 16 minus 1, so it becomes 15. So I think you can see one thing, that if you are able to do questions of permutation and combinations, they will be very easy to do. Okay, because they are done in the least amount of time. Okay, so now let us look at this. A person has 4 coins in each of different denomination. Okay, we have 4 coins are there in each of different denomination. What is the number of different sums of money the person can form using one or more coins? The similar kind of answer, 4 coins, different denomination, 2 to the power 4 minus 1, so that this will come 15. Okay, the same question has been given in different ways. Now see, look at this question. Look at this question. How many 3-digit numbers can be generated from 1, 2, 3, 4, 5, 6, 7, 8, 9, such that the digits are in ascending order? Okay, such that the digits are in ascending order. How many 3-digit numbers can be generated from 1, 2, 3, 4, 5, 6, 7, 8, 9, such that the digits are in ascending order? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, now 9, how many digits are there? 9 digits are there. And you are saying that the digit should be in ascending order. Okay, so if we are choosing 1, 2 and 3, we can choose only that. Then we can choose 2, 3 and 4. Then we can choose 3, 4 and 5. Then we can choose what? 4, 5 and 6. 6, 7 and 8. 7, 8 and 9. Okay, and this much only, because if we do 8 and 9, so that is not possible. So this you can see that digits are always in ascending order. Okay, now we have to find 3-digit number. Okay, we have to always find 3-digit number. So but if you are like, let us say, considering this 1, 2 and 3. Okay, so then another combination could be 1, 3 and 4 as well, 1, 2 and 4 as well, 1, 2 and let's say 5 as well, 1, 2 and 6 as well, 1, 2 and 7 as well, 1, 2 and 8 as well, 1, 2 and 9 as well. So you can arrange them in any number of ways, but how are we going to find this mathematically? Okay, how are we going to find this mathematically? Okay, so let us do this. Now see, so if we like consider 1, 2, 1 and 2, okay, if we are considering this case 1 and 2, then now when we have fixed here 1 and 2, then how many numbers we can put here? Out of how many numbers? Okay, so if we are choosing this 1 and 2, how many ways we can put number here? 7 numbers. Okay, we can put 7 numbers. Similarly, let's say if we are choosing 1 and 3, so we can put 6 numbers. If we are choosing 1 and 4, we can put how many numbers? 5 numbers. 1 and 5, only 1 and 5, only 4 numbers we can put. 1 and 6, only 3 numbers we can put. 1 and 7, only 2 numbers we can put. 1 and 8, only one number we can put. Okay, so from like 1 to 7, how many numbers we are getting? 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Okay, so this is how much? This is 13 plus 5, 18 plus 3, 18 plus 4, 22. 22 plus 3 is 25, and 25 plus 3 is 28. So when we are having this 1 2 combination, so we are getting how many number? 28 numbers. Okay, we are getting how many numbers? 28 numbers. Fine. Sorry, this 1 2 1 3 till 1 8 combination. So we are getting how many numbers? We are getting 28 numbers. Okay, so we have seen this case. Now let us see numbers starting from 2. Okay, so if we are saying numbers starting from 2, so we can put 2 3 here. Okay, we can put 2 3 here, and then how many numbers? Then you have this 4 5 6 7 8 9. Okay, 4 5 6 7 8 9, because if 2, then you will put 3 here. So how many numbers will be there? 1 2 3 4 5 6. Okay, 6 numbers. Okay, then if you put 4 here, how many numbers? 5 numbers. If you put 5 here, how many number? 4 number. If you put 6 here, how many number? 3 number. If you put 7 here, how many number? 2 numbers. If you put 8 here, how many number? Only 1 number. So just calculate 6 plus 5 plus 4 plus 3 plus 2 plus 1. How much is there? So you have this as 15. Okay, you have this as 15. Okay, earlier you were having 28. Okay, now you have 15 choices. Okay, now how many choices you have? 15 choices. Fine. Now we'll start with 3. So you will have 3 4. Okay, so how many number? 5 when you are having 3 5, 4 when you are having 3 6, 3 when you are having 3 7, 2 when you are having 3 8, 1 only. So this become 5 plus 4 plus 3 plus 2 plus 1. So basically what is happening, in each of them, this number we are eliminating. Okay, this number we are eliminating. So first when we got this, we had 28 numbers, then we had 15 numbers, then it came down to how much? 5 plus 4 plus 3 plus 2 plus 1 is how much? This becomes 3 plus 5, 15. Guys, look at this question, what this question is saying. How many three-digit numbers can be generated from 1, 2, 3, 4, 5, 6, 7, 8, 9 such that the digits are always in ascending order? So we have to always keep the digit in ascending order. We have to make a three-digit number. So how we can make? Actually like 1, 2 and 3, then 1, 2 and 4, then 1, 2 and 5, then 1, 2 and 6, 1, 2 and 7, 1, 2 and 8, 1, 2 and 9. So this way they are asking. Okay. So for example, we are taking these first two digits as 1 and 2. Okay. So in how many ways we can form all these numbers? Now we can put any of these 7 digits. So we'll have 7 numbers because we are putting 1, 2 and 3, 1, 2 and 4, 1, 2 and 5, 1, 2 and 6, 1, 2 and 7, 1, 2 and 8, 1, 2 and 9. Similarly, we are taking 1 and 3. Okay. We are taking 1 and 3. Then we can't choose this 2. So we'll choose from any of these number. So these are how many numbers? 6 number. Okay. And if we are taking 1 and 4, then we can take from these 5 numbers. Now if we are taking 1 and 5, then we are taking from these 4 numbers. If we are taking 1 and 6, then 3 numbers. If we are taking 1 and like 7, so then you will have 2 number, 1 and 8, then you are having this number. So this is what? 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. What is this? This will be 28. Okay, so this is one case. Then let's say you are having this 2. Okay, 2 as the first number, so we'll keep 3 as the second number. So how many numbers you can make? Okay, now 1 2 sorry, 2 and 3 we have fixed, we can't take 1. So out of these 9 numbers, how many numbers are left? 6. If we are taking 2 and 4 combination, then this last digit can be filled by 5. If we are taking this 2 and 5 combination, then last digit by 4. Similarly for 2 and 6, 2 and 7, and 2 and 8, we'll have 3, 2 and 1 number. So this you add, how much is coming? 21. Okay, because 6 plus 5 is 11, 11 plus 4 is 15, 15 plus 3 is 18, and 18 plus 3 is 21. Then you will have this 3 and 4. Okay, and then this one place will be left. Okay, 3 and 4, and this one place will be left. So you will have this 3 and 4. Okay, and then 3 and 4, and then this can be done in 5 ways. Okay, and when this 3 and 4 can be done, okay, 3 and 4 can be done, then this can be done in how many ways? 4 ways. Okay, 4 ways. And when so if we are taking like 3 and 5, then this can be done in 4 ways. For 3 and 6, 3. For 3 and 7, 2. For 3 and 8, 1. Okay, so 5 plus 4 plus like 10, and this is 15. Okay, 15. Now 4 and 5. Okay, 4 and 5. So this can be done in how many ways? This can be done in 4 ways. 4 and 6, this can be done in 3 ways. 4 and 7, this can be done in 2 ways. 4 and 8, this can be done in 1 way. Okay, so this will become how much? This becomes 10. Okay, so see what we are doing: 28, and then 21, and then 15, and then you have what? This as 10. Okay, so now you are seeing, you subtracted 7 here, you subtracted 6 here, you subtracted 5 here. Okay, then you subtract 4 here. So now 6 number are possible if we are doing 5 and 6 combination. Okay, and then 5 6 5 7 5 8. So how many number are possible from this 6? Because 5 6, this will come to be 3 numbers. 5 7, 2 numbers, and 5 8, 1 number. So 6. Okay, now subtract 3 here. So how much you will get? 3 numbers. So that is 6 7. So if we are 6 7, so we are left with 2 numbers, because you can put either 8 here or 9 here. If we are doing 6 8, then only 1 is left, so 3. And then subtract 2 here, then only one number, that is 7 8 9. Okay, 7 8 9. Now you add all these numbers. You add 28 plus 21 plus 15 plus 10 plus 6 plus 3 plus 1. Okay, so how many what is the sum you are getting? Okay, what is the sum you are getting? This is 4 plus 6 10, 10 plus 5 15, 15 plus 1 16, 16 plus 8 is how much? 24. Okay, 16 plus 8 is 24. To carry over, you have this as 6. 6 plus 2 is 8. You get 84 numbers. Okay, you get 84 numbers. So in this, actually you have to make your combinations. Okay, you have to make your combination, but it is not that difficult. Okay, it is not that difficult, because once we realize, just do 1 2. Okay, then you observe that for the first place you are getting 7 numbers. Okay, for the second place you are getting 6 numbers. For the third place you are getting 5 number. Okay, sorry, for 3, for 4, for 5. For 5 you will get 4 number. For 6 you will get 3 number. For 7 you will get 2 number. For 8 you will get 1 number. Now when you are doing next term, so you observe that it starts from 6 and end in 1. Okay, then when you are doing the next one, then you know it starts from 5 and ends in 1. Okay, so just add this. So when you add this, you get 28. Then you subtract 6 from this, you get 15. Then you subtract 5 from this, then you get 10. Then you subtract 4 from this, you get 6. Then you subtract 3 from this, you get 3. Then you subtract 2 from this, you get 1. Okay, then you add all of them, then you get 84. So I hope you understood the logic of the question very well. Okay, so this is how you can do these kind of questions. Okay, now let's move forward. Okay, now look at this question. What this question is saying, let us understand. It is saying, in a carom board game competition, M boys and N girls of a school participate. Okay, and the number of boys are greater than number of girls, in which every student has to play exact one game with every other student. Okay, so every student has to exactly play one game with every other student. Out of the total games played, it was found that 221 games, one player was a boy and the other player was a girl. Okay, see, so there are M boys and N girls, and it is saying 221 games. In 221 games, boys and girls were against each other. Okay. Now, what the question is asking, it is asking the total number of students that participated in the competition is 30. Okay, the total number of students which participated in the question is 30. Okay, so m plus n is equals to 30, they are saying. The number of games in which both players were girl is 78. Okay, the number of games in which both players are girls is 78. Which of the following statements are correct? So we have to we have to check the authenticity of these statements. Okay, we have to check the authenticity of these statements. Fine. So, see what is happening in this question, that uh, if we are taking there are m boys, okay, and there are n girls, fine. So, if one boy and one girl is playing, so basically we have to choose one boy from here and one girl, girl from here, okay. So, see what this is saying, that MC1 into NC1 is equals to 221. Okay, because see, you can choose boys in how many ways? You can one boy, if there are m boys, then you can choose boys in MC1 ways, and one, and you can choose this in NC1 ways. Okay, now let us consider this 221. Okay, let us consider this 221. Okay, so how this 221 can be factorized? Is this divisible by 3? Okay, so we add this, we see this is not divisible by 3 because 4 plus 1. Okay, so let us check this by 7. Okay, so 7 is what? 7 threes are 21, and again this is not divisible by 7 as well. So let us check 13. Okay, let us check by 13. So 13 one times. Okay, 13 one times, you will get here how much? 9. Okay, this will become 0, this will 1. So 13 into 7, if we do 7 threes are 21, 2 9. Okay, so this is coming to be 91. Okay, this is coming to be 91. So that means uh, this is 17. Okay, this is 17. Okay, so now it is saying that see, either the number of boys can be 13. Okay, because 13C1 is what? 13C1 is 13 only. Okay, because 13, okay, one time and then divided by 1, because this is how you open it. Okay, or you can check by this also, 13C1 by formula. If you check factorial 13 upon factorial 1 divided by factorial 12, you will get. Okay, so that will be 13 only. 13C1 is 13 only. And let us consider that number of girls are 17. Okay, let us consider that number of girls are 17, but see, in the question, it is clearly given to us that m is greater than n. So m means what? Number of boys is greater. So we'll not consider number of boys as 13. Okay, because see, this what I am doing here is this 221 is there. So this is equal to 13 into 17. So either one of them is 17 and one of them is 13, but it is clearly saying that m is greater than n. So I am considering the number of boys as 17 and the number of girls as 13. Okay. So the total number of students 17 plus 13 is 30. So this is correct. Okay, this is correct, that the total number of uh, students are 30. Okay, but let us look at the second statement. What the second statement is saying to us? The second statement is saying the number of games in which both players are girls. Okay, so number of girls are 13. Okay, number of girls are 13, and number of girls are 13. And see, in each game, one each player has to exactly play one game with every other student. So how many games will be there? 13C2, because every girl will play with every other girl. Okay, so 13C2, so 13 into 12 divided by 2 into 1, so this becomes 6. So 6 3 6 are 18 and 1 78. So this is also true, this is also coming to be true. So both 1 and 2 are true. Okay, both 1 and 2 are true. So what is happening in this question? Let us understand once again. The question is saying to us that it is a carom board game competition, and in this competition there are m boys and n girls of a school, okay, in which every student has to play exactly one game with every other students. Now out of the total game played, it was found that 221 games, one player was a boy and another player was a girl, okay. So see, it is giving to us, it has already given to us, there are m boys and n girls, okay. And see, the number of games in which boys and girls are against each other is 221. So that means we would have chosen one boy from this m, okay. We would have chosen one boy from this m, and one girl we have chosen from here. So that is given by what? MC1 into NC1. Okay, MC1 into NC1. So MC1 is what? This is our combination. Okay, is equals to 221. Now we factorize this. Okay, so we found out that these has only two prime factor, 13 into 17. So there is only one possibility, that either number of boys are 13 or number of girls are 17, or number of girls are 13 and number of boys are 17. But it is already given to us that number of boys are greater than number of girls, so we consider number of boys as 17 and number of girls as 13, okay. So now it is asking the total number of students participated in the competition. So we have 13 plus 17, that is 30, okay, that is 30. Now it is asking the number of games in which both the players were girls is 78. So see, if one student has to play exactly against one student and girl have to play against them, matlab, one girl has to play with every other girl, so that can be done in how many ways? 13, see, two ways. So this will be 13 into 12 divided by 2 into 1, okay. So this comes out to be 78. So we find this both 1 and 2 are good, okay. Simple question, looks difficult. Now see, if this question comes into the examination, so the question looks so big, so you are intimidated by the length of the question. But you see, this question is very simple, this is not that difficult, okay. So see, be always confident with the question who in which a very big statement is given. Oh, because why? If a big statement is given, be very assured that too much information is given. When too much information is given, then you have to think more, you have to just use the information, okay. So be very confident with a very big question which comes into the examination. Don't be intimidated by big questions, okay. So let us move forward for the next question. Now look at this. In how many different ways can all of 5 identical balls be placed in the cells shown above, so that each row contains at least one ball? Okay, each row contains at least one ball. So there are 5 identical balls. So that means we only have to select from these boxes. Okay, we have to select from these boxes. Arrangement is not important. Okay, arrangement is not important. When identical word is given to you, then arrangement is not important, because see, you keep anything anywhere, we don't care about that, okay. So it is saying in how many ways can all of 5 identical balls be placed in the cell shown above, so that each row contains at least one ball, okay. Each row contains at least one ball, fine. So you have 1, 2 and 3, okay. So let us start with this, okay. So you have 5 identical balls placed in the cell shown above, such that each row contains at least one ball, okay, at least one ball. So in how many ways you can do this? See, if there are 5 identical balls, okay, each row has to contain, so either you can place one ball here, one ball here, one ball here, and one ball anywhere, okay. One ball here, one ball here, and one ball anywhere, okay. Or you can put two ball here, or you can put one and one ball, and then one and one ball anywhere, okay. So you are understanding what kind of arrangement we are trying to make. I'm just, see, we'll calculate this by method of combination solely, okay. But we are just trying to visualize what is happening here, okay. So each row we have to put, so either we can put here, here, here at least one ball, okay, here, here, here at least one ball, here, here, here at least one ball, okay. Okay, so let us consider this. So in this first case, what we are doing, okay, in this first case, what we are doing, that we are placing one ball in one of these rows. Okay, one ball in one of these rows. So at least one ball we have to place in one of these rows. Okay, so in how many ways you can select from these three boxes? 3C1 ways. Okay, and similarly from all these three boxes, 3C1 ways, or and from all these three boxes you can do this in 3C1 way. Okay, so now let us consider in how many ways we can place these. See, when you're having these five balls, okay, so at least one ball should be in there. So let us take that we are taking this top row. Okay, so what I'm saying, let us first put three balls here and one ball here. So this is one kind of arrangement. Okay, this is one kind of arrangement. So that can be done in how many ways? Okay, see, when we have to put all three balls in here, okay, so that can be done in one way. But when we are putting balls here, so we have to select from one of these boxes, so that can be done in 3C1 way. Okay, that can be done in 3C1 way, and similarly when we have to put in one of these boxes, that can be done in 3C1 way. Okay, that can be done in 3C1 way. Okay, but see, either we can put three balls here, or we can put three balls here, or we can put three balls here. So there will be three cases of doing this. There will be three cases of doing this. Okay, so either we can put all the three balls here, or all the three balls here, or all the three balls here. So there will be three ways of doing this thing. Okay, now let us consider the second case. So we are putting what, first we are putting 311 we are taking. Okay, now let us take there are five balls, so we can take 2 2 1. Okay, 2 2 1. So let us think that we are placing two balls here and one ball here. Okay, so two balls, when we are taking the arrangement 2 2 1. Okay, when we are taking the arrangement 2 2 1, so in how many ways we can do? See, you have to select from these three boxes, two boxes. So that can be done in 3C2 ways. You have to select from this 3C2 ways, and you have to select from this 3C1 way. Okay, 3C1 way. Now this one ball can either be here, or be here, or be here. Okay, so there will be three cases. There will be how many cases? Three cases for this. See, either you can put like what, 2 2 1, what can be the arrangement, that you are putting two balls here, or two balls here and one ball here, or you can put two balls here, two balls here and one ball here. Okay, so there will be three cases, so we multiply this by 3. Is there any other case? Is there any other case? See, we already did 311, we did 211. Okay, so there are only two cases, and we have calculated what are the possible number of uh, um, combinations for that. Okay, so 3C1 is given by 3, 3C1 is given by 3, and 3C1 is given by 3. So this becomes how much? 3 into 3 into 3. So that is 27. Okay, now let us look at this. What is this? 3C2. 3C2 means this can be done in how many ways? 3C2 means 3 only, because 3 into 2 and 2 into 1. So this means 3 only. This means 3 only. This means 3 only. 3C1 is also 3C1 is also 3, and 3C2 is also 3, because 3C1 you do now, you'll get 3 only. And then you have 3. Okay, so 3 into 3 is 9, and 9 into 3 is 27, and 27 into 3 is 81, and you have 27 more here. So you get how much? You get 108 here. You get 108 here. See, this kind of question was asked in the UPSC last year. Okay, so in this you just have to, like, you have to select cells. So you have to, like, understand that what kind of selection of the cells you can make. Okay, let us consider this question once more for better understanding. See, what we are asked is in how many ways we can arrange. Okay, five identical balls. So when five identical balls are there, arrangement is not important, only selection is important. And that too, selection not of the balls, selection of these boxes. Okay, so when I have these boxes, so five identical balls in these boxes, and I have to put one ball in at least each row. Okay, one ball in at least each row I have to put. So I can put one ball here, one ball here, and the rest three balls I can put here. Okay, so when I am putting all the three balls in one row, so the number of ways of doing that is one only. And when I am putting one ball in one of these boxes, so that can be done in 3C1 ways. And when I am putting one ball in any one of these boxes, so that can be done in 3C1 way. So we are doing what? 3C1 into 3C1 into 1. Okay, so that will be 3 into 3 into 1. So that is equal to 9. Okay, this can be done in three ways, so that is equal to 27. Okay, now you have this. Okay, now you have this. Okay, so now what we are having here is one case we have already considered 311, and then one case is 221. Okay, so this is what we can do here is we can choose two places here, we can choose two places here, and we can choose one place here. Okay, so what we can do, we can select this in 3C2 ways, we can select this in 3C2 ways, and we can select this in 3C1 way. Okay, so and this is the type of the selection we can make. And see, either you can put 2 to 1 this way, or you can put 2 to 1 in how many ways? 2 to 1, or you can put 2 uh, 2 to 1. So three ways we can do this. So we'll multiply this by 3 as well. Okay, we'll multiply this by 3 as well. So this will become what? 3 into 3 into 3 into 3. So this is this becomes 81, and 81 plus 27 is 108. So this is simple, but this kind of question has already been asked in the UPSC. Okay, this is another question which is past year UPSC question. Now this is very simple. This just requires the application of your brain. Okay, so there are 6 different letters and 6 correspondingly addressed envelope. If the letters are randomly put in the envelopes, what is the probability that exactly 5 letters go into the correctly addressed envelope? Okay, so see, let's say we are given A, B, C, D, E, F. Okay, these are the letters. Okay, and their corresponding envelopes are, let's say, A dash, B dash, C dash, D dash, E dash, F dash. Okay, so they are saying that if 5 letters go into the correctly addressed envelope, then what is the possibility that exactly 5 letters go into the correctly addressed envelope? Okay, so see, when we are calculating probability, okay, when we are calculating probability, what we are doing exactly is the total number of cases possible. Okay, the total number of cases possible divides the number of cases given in the condition. Okay, so it is saying now the total number of ways in which 6 letters can go into the envelope is into the correctly addressed envelope is 6. Okay, because A will go into A, B will go into B, and so on. Okay, and the total number of the cases of the condition is 5, because 5 letters are going into the correctly addressed envelope. So the probability should be 5 by 6, but this is wrong. Why? See, understand this thing. If there are 6 letters and they are addressed to 6 correctly addressed envelope, so 5 letter I am putting in the correctly addressed envelope. So the letter that is left, that also I will put in the correctly addressed envelope only. If I am putting 5 letters in the correctly addressed envelope, then I am putting the last letter which is left, then only one envelope is left. So that will be put in the correctly addressed envelope itself. So the probability when 5 letters go into the correctly addressed envelope, so the probability that the letter remaining will go into the incorrect addressed envelope will is 0, because only one envelope is left and that is addressed correctly only. So this becomes 0. Okay, so this becomes 0. It is a trick question. It is trying to like just trap you. It is a very easy question, but a trick question. Okay, so here no aptitude will come. It is just whether you are able to think about the condition. Okay, so that is why whenever I am teaching you permutation and combination, I am telling you try to visualize the situation. Okay, so for example, in this way, A, B, C, D, E, F. Okay, And A dash, B dash, C dash, D dash, E dash, and F dash are envelope. So A goes into A dash, B goes into B dash, C goes into C dash, D goes into D dash, E goes into E dash. This is the condition. So this last one will go where? In its own envelope, nowhere else. Okay. So 0. Okay. So this is the how UPSC is trying to trap you. Okay. Fine. Now let us do one more question here. See, it is saying there are two identical red, two identical black, and two identical white balls. In how many different ways can the ball be placed in the cells? Each cell to contain one ball shown above that. Such balls of the same color do not occupy any two consecutive cells. Okay. So what it is saying, there are two identical red balls, two identical black balls, and two identical white balls. Okay, in how many ways can the balls be placed in the cells? Okay, we have to place these balls in the cells such that balls of the same color do not occupy the consecutive cells. Okay, such that balls of the same colors do not occupy the consecutive cells. Okay, now see what is there. We are having how many total number of balls we are having? How much? We are having 6 balls and we have to fill 4 places. Okay, we have 6 balls and we have to fill 4 places. Okay, now see in this 6 balls, see we cannot choose, we are having 2 balls of one color. Okay, so either it can be you choose 2 red balls and 2 black balls and place them alternatively. Okay, so that is one case. Okay, or you choose 2 black balls and white balls. Okay, and you place them alternatively. Okay, so that is one case. Okay, that is one case. Or you choose red and white ball and place alternatively. So that is one case. So number of cases you get are 3. Okay, when you are choosing 2 and 2 balls. Okay, and now when you are choosing 3 balls. Okay, so let's say you are choosing 1, 2, 3 balls. Okay, so that is one red you chose, one black you chose, one white you chose. Okay. Now the fourth ball can either be white, black, or red. So the number of cases you are getting is how much? Number of cases you are getting is 6. Okay. So I hope you are understanding this. Okay. Now I hope you are understanding this. So but red, white, and let's say black you are red, black, and white you are putting. So here either you will put red or you will put black. Okay, you can't put white here. Okay, you can't put white here. So I hope you are able to understand what kind of arrangement. Okay, so I hope you are getting what kind of arrangement we are making here. Okay, but now let us try to solve this thing mathematically. Okay, so see, these are what? These are 6 ball, but these are identical balls. So total to put here, you have how many choices? You have 3 choices to put here. Okay, you can put out of these 3 red, black, and white ball, you can put 3 balls here. Okay, but now the color you have put here you can't put here, so you are only left with 2 choices. Okay, you are only left with 2 choices. Also the color you have put here you can't put here, but you can put this color here. So now also you have 2 choices. Okay, and the color that you have put here you can't put here, so just eliminate that. So out of 3, how many choices you are left? 2 choices you are left. So the answer will come to be 3 into 2 into 2 into 2, which is 8 into 3. So that is 24. Okay, so I hope you understood the arrangement what this is asking, but this can be done mathematically. This is very simple. You have red ball, you have black ball, and you have white ball. Okay, you have 4 places, 1, 2, 3, and 4 places. So when you are taking red balls, okay, when you are taking the first place, okay, so you can select from either of these 3 balls. See, you won't select from 6 balls. Why? Because these are identical. Okay, so you have 3 choices. Now if you, for example, you have chosen red here, so you can't choose red. So in how many ways you can put here? 2. When you are choosing this place, so you can't put like black or white if you are choosing. So in how many ways you can do this? 2 ways. And how many ways you can do this? 2 ways. So that comes to be 3 into 8, so that is 24. Okay, so I hope you are clear with this thing. Let's end this here.